welcome everybody. This is the talk made by me, Davide Borsatti from the University of Bologna, and Whitestack, and that Sergio Tarazona will be the one speaking for them. And it's, let's say, a preliminary work that aims to demonstrate how MEC application can be deployed and managed with OSM. So it should be seen as kind of the first step that OSM could make toward a MEC support. So I think we can start. So yeah, the presentation will be divided into two parts. One in which I will just briefly explain a bit of MEC principles that could be useful for you, even for the future, and also be useful to understand the demo. And then finally, a live demo that will be done by Sergio. Okay, so let's start with the more, let's call it theoretical part. And what is MEC? MEC stands for Multi-Access Edge Computing, is an IST from ETSI, and it aims at kind of standardizing what is the structure for hosting application in an edge environment. And so the idea here is to provide a standardized environment in which this application can run, and to provide standardized interface that this application can use to get even information for the network itself. The idea here is that the application can maybe get access to information about, for example, the radio access network, or for example, the cell that a specific user equipment is using, or so anyway, other, let's say, information about the real world, or where the consumer of this application lives. So what the IC did is they defined an architecture, which is on in the next slide. Yeah, and yes, so they defined an architecture for managing this system. For those of you which are familiar with the NFV MANO standards, you should see some similarities. But the idea here is to have two separate layers. One is the MEC system level, in which the orchestrator resides, basically has a similar functionality as the NFVO in NFV. And its aim is to get a general view of the whole MEC system and orchestrate the resources by getting the request from a, for example, OSS VSS component on top. Then we have the MEC host level, which is the level in which the application will actually reside. Specifically, we have a MEC platform manager, which is the object that will talk with the infrastructure, virtualization infrastructure, to deploy and manage the life cycle of application, and of this new object, which is called MEC platform. What is a MEC platform? You could think of it as kind of a point of presence inside your virtualization infrastructure, and its aim is to ease the interaction between application. In MEC environment, MEC application can offer service to be consumed by other application. And what the MEC platform is, let's say, taking these service registration requests and then exposing them to other MEC application that might be interested in that specific service. Furthermore, the MEC platform also handles DNS name resolution, and also is able to program the data plane to manage the traffic accordingly. As I said, there are a lot of similarity with the NFV world. So what the ISG did, they also provided a version of this architecture that relies on pre-existing NFV functionality, which is the so-called MEC in NFV architecture that we can see in the next slide. And as I said, the idea here is to reuse pre-existing blocks from NFV to integrate the missing functionality that MEC may require. So next slide, please. Thank you. As you can see here, the Mac platform and the other Mac application runs as VNF. So they can be treated as VNF. Therefore, also their life cycle can be then managed by their specific VNFM. So both the Mac application and the Mac platform will be treated as a standard VNF. So their life cycle will be managed by their VNFM. And also most of the management of this Mac application can be delegated to the NFVO that can manage Mac application as VNF part of one or more network services. And of course, there are, let's say, some missing functionalities. For example, there might be orchestration part that are more specific to Mac. For example, because there are specific requests that might come up from the end user that the NFVO is not able to, let's say, to solve. And for that, there's the Mac application orchestrator, which does, let's say, everything else. So everything that more that we need with respect to reach, let's say, the Mac goals with respect to standard NFVO. And then we have the Mac Platform Manager, which does all these other management functionalities for the Mac application that the standalone VNFM cannot do. And between these, let's say, components, of course, we may need new interfaces that are highlighted in the next slide. And so these are, let's say, hybrid reference point. And yeah, next slide, please. Sorry. Yeah, thank you. And let's say these are hybrid reference point, meaning they connect these two words, so the Mac word and NFV word in a sense. And some of them can be practically be considered as equal to pre-existing NFV reference points, such as the MV3 there. While for other, there might be some changes needed to make this work working correctly. As for example, the MV1, but again, there's not still a precise definition for these interfaces. There's work going on in the group as well. Okay, and this kind of was just, let's say, a brief introduction to the Mac architecture, so the architecture of Mac system. Again, there's no lot of time to go through in deep with all the details here, but of course, if you have questions, I'm more than happy to answer you whatever curiosity you might have. So to continue, I will like to point the attention to the interaction standardized in Mac 11 documents, which are the one that, or let's say, happens between Mac application and the Mac platform. Specifically, I will try to focus on the service part, which will be the one that we will also see used during the demo later on. So Mac 11's standardize some of the interaction that happens in the MP1 interface, which is the one between the Mac application and the Mac platform. And through this interface, Mac application can register the service, gets the list of available service offered in the system, and maybe also ask for particular DNS configuration or particular data plane programming, a specific data plane programmability. And I will then highlight some of these interaction that, again, as I said, will be the ones that we will actually see in the live demo. The first one is the most simplest one, and is the one that the Mac application instance uses to let the Mac platform know that it's up and running and is ready to do, let's say, its duty. And This, of course, will be one of the first call that the MEC application will do right after the deployment. And again, as I said, we will see this in the demo. Then we have a service registration. So a MEC instance, once it has been deployed, could, for example, register its service. What does registering a service mean? It means that the MEC application will let know everybody else that might be interested that is offering a specific service that they can contact using a specific endpoint. But we will see an example of this service format, let's say, in the demo part. Finally, the other interaction that we will also see in the demo is the one in which we will have a service consuming MEC app that will get the list of required service, and if the service that is looking for, or the service that might do whatever it needs, this new application needs, it can get it from the service list, and then get from this service list the endpoint, so how to contact the service that is providing this required service, let's say, and then start the consumption. And again, this will be exactly what we will see during the live demo. So we will have an application that will register its service, and then we will have another MEC application that automatically will get the service list, check if there's a service matching with a particular parameter, for example, and it will automatically consume it using, again, this standardized interaction that were standardized by the ESG. And I think that this more or less concludes the more theoretical part, and we can go on with the demo.
Thank you,
Of course.
Davide.
Thank you.
Okay, and if we have any question, I think we will have time at the end of the demo, so we will continue right now. Okay, so now we're going to present this MEC demo using WhiteNFV. This is a OSM product from Whitestack. So we're going to test the MEC platform using two MEC apps designed by University of Bologna. WhiteNFV will be used to orchestrate the MEC platform and applications. WhiteMist, this is a Kubernetes distribution from Whitestack, will be the cluster environment. And we will test the interactions based on ETSI standards, as Davide mentioned previously. The MEC apps running, the service registration, request service list, and the service consumption. Okay, so let's move to the WhiteNFV. So we're going to create first the MEC platform. I have the descriptors already loaded, the platform. And then I'm going to create the two applications. I have here some parameters that I'm going to pass to the application. Okay. So now I have two, the MEC platform and one application running. So we'll wait for the second one. Okay, the three are ready. So we can check in the cluster. that the 3 pods are running. So I'm going to get the service in the applications. The other one. I have the 2 applications. So I'm going to check the configuration. It's okay. Here the configuration is okay also. Okay, now the first interaction is the confirm ready. So I'm going to confirm it. Since it's supposed to be no reply, that's why we don't see any reply. So I'm going to check. Okay, it's already in ready state. So services, right now there's no service. So I'm going to register the service from this application. Okay, the new service is created. So I'm going to see how it looks like in this JSON viewer. So here I can see that the new service, the name is MEC test service, and the state is active, and we have the URI. Okay, it's related to the API tester 01. Okay, for now I have registered one application, so I'm going to register another one. Same as I did before. Confirm ready. Now I'm going to register the service. Okay, and now I'm going to get the list of services available. So right now I have 2 services. The first one that we saw previously, and now I have new service in active state, and it's called, and its URI is API tester 02. Okay, now I'm going to see the interaction between this application and the other one. So I need to get this service name. I'm going to pass it. And then I can see the interaction. So this message confirms that the service, that the application, the other application service is active. So that's it. It's pretty simple. So I'm going to see what we've done here. We did this, this. Okay. So what we did, okay, we were able to deploy MEC platform and 2 apps on top of Kubernetes cluster. Yes, we orchestrate these 2 apps and the MEC platform. And then we test these interactions between applications and MEC platform. And every interaction is ETSI compliant, as Davide mentioned before. So that's it. Thank you very much. I don't know if you have any questions.
Okay. Maybe since there's time, while we wait for questions, I might add, let's say, a bit more details on what exactly the application are doing. These are application we developed just for test MEC interaction, so for test the API standardized by the group, by the SG. And what they're doing is exactly what you saw in the diagrams before. So they are checking and registering service, which are the format that Sergio just showed to you. Maybe we could go back a bit on the service definition. What do you think, Sergio? So we can talk a bit more about that.
Excuse me?
Yeah, next slide is okay.
This one?
Yeah. What you see here is the service definition of Mac 11. And what the information that you see here is basically the details of the type of service that a specific Mac application is providing. So the most important part, of course, is let's say the endpoint, which specify how you can contact the that particular application. In this case, is in the form of URI, but you can also specify IP, the couple IP port or something like that. And also then contains information of what type of service is. If you, for example, in this case, is using a protocol, which is HTTP in this case. So you can, let's say, describe how the service is, what kind of service you're exposing and how you can contact it. And all of this is contained in this standardized format that other application can then use to consume your service. Again, it is all following the standardized API described in Mac 11. Okay. Of course, if you have any question, any curiosity, we are here to answer